This video is about solving exponential equations, and what I mean by that is when the exponent holds our variable. So when you look at this equation, it's pretty obvious that if you have 2 to the x power equals 2 to the 7th power, that this x and this 7 must represent the same quantity in order for them to be equal. So the answer is x equals 7. Now when you look at this problem, I have exponents, but the bases are not the same, so I cannot do what I did in the last problem. However, 9 can be written as 3 squared. So if I do that, then I can look at my problem and I see that I've got 3 to a power equals 3 to a power. So I can set x minus 5 equal to 2. They must represent the same quantity. And to solve that, I just need to add 5 to both sides. And my answer is x equals 7. That means in order for this to be true, I would have to put a 7 in there. So let's do a quick check. 3 to the 7 minus 5 equals 9 to the first. So that means 3 to the second equals 9 to the first. 9 equals 9. It checks. Okay, here's the next problem. Notice that I have a 5 here and a 125. Over here I have written down, you must get the bases the same in order to set the exponents equal. So I'm going to go over to this number right here, and 125 is the same as 5 times 5 times 5. So I can write that as 5 to the third. So what I end up with is 5 to the 2x minus 3 equals 5 to the third. And since the bases are the same, this quantity must be the same as this quantity. So I've got 2x minus 3 equals 3. I add 3 to both sides, and I get 2x equals 6. Divide by 2, and x equals 3. Let's do a quick check. If I put 3 in here, 2 times 3 is 6. 6 minus 3 is 3, and 5 to the third is indeed 125. So the key to all of these problems is to get the bases to be the same. This one is a little more challenging because I don't have an obvious base picked out, plus I have a fraction. So let's look at the left side first. 27 is 3 times 3 times 3. So 27 is 3 cubed, but I also have that x on the outside. So that simplifies to 3 to the 3x, because when you raise an exponent to an exponent, you multiply them. Okay, over on the other side, 81 is 3 times 3 times 3 times 3. So this is the same as 1 over 3 to the 4th power. And if you have something in the denominator and you want to kick it upstairs, or if you have an exponent anywhere and you want to kick it to the other part of the fraction, you have to change the sign on the exponent. So 1 over the 3 to the 4th is the same as 3 to the negative 4th. So now I have successfully written both of those terms as 3 to some power. That means that this quantity must equal this quantity. 3x must equal negative 4. So if I divide by 3, x equals negative 4 thirds. Okay, here's our next problem. If I look at 4 and 32, both of those numbers can be written as a power of 2. So I've got 4 to the 2x minus 5. And if I look at the number 4, that's really a 2 squared. Over on this side, 32 is just 2 to the 5th power. So now you need to be careful here because I need to raise this exponent to this exponent. So I have to multiply the exponents. It looks like this if I write it out as multiplication. My point here is make sure that you do distributive, because you need to multiply 2 times that entire exponent. So we end up with 2 to the power of 4x minus 10 equals 2 to the power of 5. And now since I have 2 to both powers, I can set the exponents equal. I've got 4x minus 10 equals 5. Add 10 to both sides, and I have 4x equals 15. Divide by 4, and I have x equals 15 fourths as my answer. Okay, here's the last problem. 2 to the x equals 0.5. Now that looks weird, because how do you write 0.5 as 2 to some power? Well, here's a little trick that might help. Let's write 0.5 as a fraction. That's 5/10, and we know that 5/10 is really 1/2. So now I've got 2 to the x equals 1/2. Well, remember that anytime you want to kick something upstairs, you negate the exponent. So 1 over 2 to the 1 power, if I kick it upstairs, it becomes 2 to the negative 1 power. Now the bases are the same, so the powers must be equal, and I've got x equals -1. So the key to all of these problems is to get the bases to be the same, and then you can set the exponents equal to each other and solve.